Hello everyone. In this session, we will explore how heap sort works by first building a binary heap, then repeatedly removing the largest or the smallest element to create a sorted array. Before going to this sorting algorithm, so first let me give the introduction to heap data structure. What is heap data structure and how heap sort algorithm works, and some examples of your heap sort algorithm applications and time complexity, all these things we'll discuss in this session. First, let us start with introduction to heap data structure. Have you ever wondered how you can sort a list of numbers efficiently using the power of trees? Yes. So this is the heap sort. It's a classic and the powerful sorting algorithm based on the heap data structure to sort the given elements. Of course, heap is also a specialized tree-based data structure and that should satisfy the heap property. What is this heap property actually? Heap property means, of course, you can construct the heap in two ways. The first one is the max heap and the second one is the min heap. I mean, in these two ways, you can construct the heap. What is max heap and what is min heap? Max heap is nothing but always the key of your parent node should be greater than or equal to its children keys. Okay, which you just take the example of left side, whatever is available here. See this part, 50 is always the greater, element. You just see this 50 is always the greater element compared to this element and as well as compared to this element and always as well as compared to these two elements, 30 is greater and compared to this 30 is greater. So this is satisfying the property of maxi. At the same time, min heap is nothing but for a given node, the key of the parent node should be less than or equal to its key element. You just take the example. This is the parent node. Parent node is having lesser than its child node. So this is satisfying the min heap property. And here 20 is less than 50 and 20 is less than 30. Both are satisfying the max heap property. So that is the best and the simple example of your max heap and min heap concept. Now, let us go to the key characteristics. What are all the key characteristics of your heap data structure? A heap is always complete binary tree, which means levels are filled except possibly for the last, and these elements are always filled from left to right. So we're supposed to follow the method. Always all the elements should be added from left to right. And what are all the operations you can perform on this heap? The first one is insertion operation, second one is deletion operation, and third one is storage. What is actually the insertion operation? Insertion operation, what happens? You're going to insert the element at the end of your list always. List is nothing but, of course, here we are going to follow array data structure to store the given elements. And always you just call a bubble up, which is heapification method to maintain the heap property. And deletion means what happens? You're supposed to replace your root element with the last element. This is called as a bubble down, which means heapified down to maintain the heap property. The third one is storage. Heap is oftenly efficiently implemented as an array, which means usually we will make use of these arrays to implement this heap. And where if you want to find the index of a particular element means, suppose if you want to find the ith index element parent node means, for that we have a formula called I minus 1 slash slash 2, which means this is called as a floor division operation. Suppose if your I value is equals to 4, 4 minus 1 is 3, 3 divided by 2 means you will get 1.5. That 0.5 will be truncated and you will get the 1, which means at array index, you are going to find the root of that particular ith position element. Similarly, left child is also calculated in such a way that We have a formula 2 star I plus 1, and right child is also calculated using this 2 star I plus 1. Let us go to this heap sort algorithm. Steps to perform this heap sort algorithm is, step 1 is, first you should build the max heap from the given input array. Here I'm giving the example of max heap. I'm not going to build a min heap. I'm just give you example of max heap. First thing is, you should build a max heap and then perform all this operation from step 2 to step 5. The second step is, you just take the largest element in the heap, which means largest element, which means always root element has the largest element, which means that is stored at the index 0 in your array. Take that element, swap your first element with the last element that is given in the step 3, and move current root node to the end of your array. After that, reduce your size of your heap by 1, ignoring the last sorted element. Next, heapify the root element again to maintain the max heap property. Follow the same steps from 3 to 5 until you get the value greater than 1. Next is, let us take one simple example and construct the heap. So this is the example 10, 20, 30, 40, and 50. First, let us build the heap. I told you already storage, how the elements are stored in your heap, which means of course we will make use of this arrays only. Here we have 5 elements, so 5 storage spaces required. So for that, I have taken this 0, 1, 2, 3, 4 as a array index element. First, let us take the element number 10. So number 10, first you create the node, insert that number into its 0th index. Obviously, this is represented in the form of heap, but the values are stored in the array only. In step 2, you take the second element and simply you just add to left side. Again, you take the third element, add that element to right side, which means second index 30 is added. Similarly, third index for number 40 is added, and fourth index number 50 is added. Simply we just simply constructed the tree, but this is not a heap. Why this is not a heap? Because this is not satisfying the max heap property. Then how to make it this particular tree as a max heap? So for that, we are supposed to follow the method. Let's see, here you have element 10, 20, 30, 40, and 50. First, what you should do, always you take the last element. Okay, you just take the last element. Here, the last element is number 50, and check whether its parent node is satisfying the max heap property or not. How to check whether the parent node is satisfying the max heap property or not? The simple thing, you have a formula. So here number 50 means number 50 is stored at index 4, which means that is the ith position. So you just take it as I value as 4. And how to find the parent node of this? So for that we have a formula. What is that formula? So here I value is nothing but whatever the value is 4. This is my 4. So 4 minus 1. 4 minus 1 means you will get 3. 3 divided by 2 means you will get 1.5. 1.5, you just remove that point 5, you will get 1, which means array index 1, this element parent node is stored. That's how you can find the parent node of a particular element. Then what to do? You just simply exchange these two elements. How to exchange these two elements? Just exchange your least element with its parent node. So once this element get exchanged, again you are supposed to maintain this maxi. So for that, you just observe here, after the heapification, after exchanging the element, what happens? Number 50 and number 20 got exchanged, and check whether your left child is satisfying the maxi property or not. Yes, here left child is satisfying the maxi property. Then what you should do? You just check that element, respective element with its parent node. Here the element is number 50. Just check this with the parent node. Okay, so here parent node is not satisfying the maxi property, then what you should do? Again, you call the heapification method and exchange these two values. And these two values got exchanged. Okay. So after value got exchanged, what happens? This is your heap. Is this binary tree satisfying the maxi property? No, because these two elements are not satisfying the maxi property. Then what you should do? You just exchange these two elements. Okay. You just exchange the number 10, number 40, and maintain the heap maxi property. So now you check number 50, 30, 40. 50 is greater than 40 and 30. This is satisfying the maxi property. And here you check 40 is greater than 10 and 40 is greater than 20. This is also satisfying the maxi property. Now all the root nodes like 40 and 50 are satisfying the maxi property. So this is how you can build the heap. And this is the final constructed heap. This is satisfying the maxi properties. And the array elements are 50, 40, 30, 10, and 20. So the elements are arranged in like left to right. Okay. So now let us start with heap sort algorithm. You just take the array elements 50, 40, 30, 10, and 20. And the same element is represented in the form of max heap uh, here. Okay. So now you just call the heapification method. How to call the heapification method? Like how to perform this sorting heap sort algorithm. So here what you should do, as the algorithm says, you just exchange your root element with its least element. Here the least element is number 20 and the root element is number 50. Simply exchange these two elements. Okay, after exchanging these two elements, what you should do, you just reduce your heap size by 1. Okay, how to reduce this heap size? Just take 50 out. And one more thing, you just check whether after exchanging this element, whatever the element is there here, is it satisfying the maxi property or not? Is it satisfying the maxi property, these two elements? No, not satisfying the maxi property. Then what we should do? Again, you call heapification and exchange these two elements. 40 goes to a root element and 20 comes to its leaf node. And again, you check with respect to number 10 and number 20. Is it satisfying the maxi property? Yes, this is satisfying the maxi property. So now nothing is required. So you just take this element and store it here. This is your sorted array. See, this is your sorted array. So this element should be arranged in popped out order. So now first element is ready. And again, you take the second element. See, for first popped out element is stored at the sorted element list. So now you have 4 elements in your heap sort. So here your heap size is greater than 1. Again, you can call the simplification method. Same thing, you just simply exchange your leaf element with its root element. So number 10 and number 40, exchange these two elements. After exchanging these two elements, you just reduce your heap size 1 by 1 and take that number 40 and store it in the sorted element order. See, here your element is stored. Okay. So then once this element got exchanged and stored here, again, we should check whether this elements are satisfying the maxi property or not. Okay. So is it satisfying the maxi property? No, this is not going to satisfy the maxi property because number 10 is stored at the root node. So then what you should do? Again, you just check where number 10 and number 30. Again, you call the heapification method, exchange these two elements. Number 30 is stored at the root node, number 20 at left side, and number 10 is at the right side. Is it satisfying the maxi property? Yes, this is satisfying the maxi property. Then uh, you just, this is the finalized one array. So 30, 10, and 20. So next, what is the size of your heap? So now your heap size is greater than 1 only. Still 2 more elements you can sort. So this is the final thing like 20, 30, and number 10. Again, you call the heapification method. So after heapification method, what you should do? To take the last element and exchange with its root element. After exchanging this root element, you just reduce your heap size by 1 and take that element and store it in the array. And one more thing, again, you should check whether this heap is satisfying the maxi property or not. So this is not satisfying the maxi property because number 10 is less than number 20. Then what you should do? Exchange these two elements. So number 20 goes to root element and number 10 will be at the least element. So now you take that number 10, 30 and store it in the sorted element list. So now one more heapification is required. Why? Because your heap size is greater than 1. So exchange number 10 with number 20. So reduce your heap size by 1 and take that element and store it in the sorted array. Now you have only one element in your heap. So heap is greater than 1. It's not greater than 1 because it is only 1. Not greater than 1 means two elements are not there, only one element is there. And finally, what you should do, that element acts as a root element and take that element and store it in the sorted element array. And this is your sorted array. So 10, 20, 30, 40, and 50. So this is how your heap sort work. The same thing you can use to build the minimum heap. In that case, you will get the elements in reverse order. Suppose if you want to arrange the elements in reverse order using max heap property means instead of following the popped out order, simply take that element and store it in some array like 50, 40, 30, 20, and 10. In that way, you will get the elements in reverse order. So both are correct only. Whichever is feasible for you people, you can make use of that. Now, what is the applications of this heap sort? So usually for data arrangements, we'll make use of this heap sort. Basically, priority queue. We'll make use of this priority queue to execute the priority step. So in that, again, we can make use of two different methods. One is lowest priority queue, another one is high priority queue. If it is a low priority queue, you can make use of min heap. If it is a high priority queue, you can make use of max heap. So both are correct only. And you can also use this heap for heap to sort the element. But this is not actually the efficient way. Uh, because other algorithms like quicksort and merge sort performs better compared to this thing. And of course, in some graph algorithms and graph application, we will make use of this heap sort. And what is the time complexity? So the time complexity means to insert the given element, of course, it takes log n. Why? Because it is going to divide your data parts into two sub half. So root element with left child, root element with right child. Similarly, to delete the root element, you need log n. After deleting the root element, what happens? Your last element get exchanged with its roots element. Again, you should follow the heapification to satisfy the max heap property. And to get the maximum element or minimum element from the given heap, the time complexity of O of n. Why it is O of n? Because always in min heap, minimum element is kept at the root node. In max heap, the maximum element is kept at the root node. So this is how you can build heap using array and as well as heap sort algorithm. If you have any doubt, you can contact me. Thank you.